Hi, everyone. It's a bit nerve-wracking to start, but my name is Raphael. Nice to meet you. As mentioned, I work in analytics and data engineering at Epic Games. However, today I'm not really here to talk about video games due to kind of reasons out of my control, but I'm very genuinely happy to be here because I'm talking about data observability, a topic that I care quite a lot about, and hopefully that you'll find, while not as directly fun as video games, still interesting. I think it has a lot of relevance for anyone who maintains and works on a data pipeline, as well as anyone who tries to extract insights from a data pipeline. So to start off with, I guess maybe some of you have heard of data observability before, but I'll give a brief introduction to the concept as a whole and go a bit into some pillars and kind of who's operating in the space, and leave you with some final thoughts on what you can do, I suppose, if you try to integrate data observability solutions into your data stack. So to start off with, hopefully this is not like too grim of a thing to do on a Monday morning, but I'm going to ask you to think a bit about the problems that you have with your data pipelines. It's raining outside, we've got the right lighting, so it's probably okay to kind of maybe think about within the last quarter, last year, an instance or two when there has been a problem that was kind of either a human error or something that was intentionally introduced and had downstream effects that caused either a component of your data pipeline to fall over or cause some issues relating to the reliability of the insights generated, which is a very common problem that you might have. So as you think about that, I suppose you have on one side kind of problems that are a bit more localized. So it could be something that's very simple, for example, like a config change or something that caused a particular part of your pipeline to not run. It could also be something that's quite distributed across your data stack. So if you imagine something like an intentional business use case, and you try to make changes to your ETL, for example, and then the changes look okay in the upstream part of your infrastructure, but when it goes downstream, it causes some issues that kind of people then are unhappy about. And now I want you to think a bit about the impact of that problem. So on one end, you perhaps have something that is very quick to notice. So it's very instant. So you might realize, for example, most commonly that you might get paged, like PagerDuty or something like that. You might get a call out of working hours saying that, why is this dashboard down? Quite common problems that you might relate to. And on the other end, you might have something that's a bit less instant. So for example, it might take a while for the problem to surface. Usually this happens through a data audit, or for example, a data analyst would kind of actually dig into the data and then say, why is this column not looking right, or why is the data missing here? And sometimes the time from the problem occurring to the discovery part can take a while. So kind of that's the other thing to think about. So I suppose among the problems that you might have in your mind of whatever your data stack currently looks like, there probably would be some component that data observability tries to address. So at its core, what I think data observability is, or at least how I started off understanding it, is data quality, which I find to be a more intuitive concept. So kind of what a lot of people, you probably have heard if you've kind of come to a talk about data that 80% of the effort usually is around cleaning data, around data processing, and 20% is about generating insights. You might have this kind of dichotomy of kind of good data and bad data. So bad data is stuff that's raw and pre-processed, and you somehow turn it into good data that can generate insights reliably from. And if you find bad data in your supposedly good pile, then that's a data quality issue. Another way that I found helpful in terms of thinking about this problem is it's usually if an analyst comes to you as a data engineer, and if they're not complaining about performance, they're probably complaining about observability. So this is kind of, as mentioned earlier, usually something like, why is this data missing? Or why has this data not been refreshed yet? And lastly, kind of, I suppose, if you have the exercise of doing a roadmap for your data infrastructure, if it is something that is kind of within the last 3 months, 6 months, etc., and it keeps getting pushed, for example, because say if you work in a small data team and you might prioritize perhaps rightfully insights generation over quality of life improvements, that is probably an observability question as well. With that in mind, I'm going to go a bit into a hierarchy of needs to unpack a bit more about what this concept practically means. I'm going to move over here. At the very bottom, you have monitoring. So this is stuff like being able to see or observe your data or data about your data. So to make it a bit more concrete, for the streaming components of your pipeline, it might be things like error rates for your pub/sub calls. It might be things like latency, which is kind of the time it takes to service a particular request, or throughput, which is kind of number of requests you service per second. For the batch components, it could be things like batch sizes. It could be things like how long it takes and how much compute it costs. If all this sounds familiar, if you kind of currently maintain a data infrastructure, a stack that involves any of these observability metrics, for example, on Datadog or New Relic, and that's no accident. So that's partially because observability as a concept has been around for a long time and has gradually evolved from kind of systems and infrastructure monitoring all the way through, and increasingly now so, applied to data processing systems. So among the newer kind of batch of metrics, you, for example, might see things like table level monitoring. You might have things like row or column level monitoring, like lineage between tables, even if you end up, say, changing a column name, things like that. So if you think about row and column level metric, this might be things like percentage of columns that are null, your values that are outliers. So your standard summary distribution of statistics of what's your median, what's your interquartile range. It might be things like cardinality, so how many unique values you have and how many you're expecting. There's also a component here around lineage, which is also getting a lot of traction. So lineage is kind of how tables relate to each other and particular objects within your data ecosystem relate to each other. And increasingly, this is kind of ML generated, as I'm sure you'll both see in some of the examples I raised today, and perhaps also in other talks that you might hear about today as well. So if you move up the hierarchy of needs, the second layer kind of addresses the needs here concern kind of the management of data incidents. So this is kind of what I just said earlier when I asked you to kind of not think in your sins, but think about what all the things that have gone wrong previously, and that's kind of things within this category. So a system that meets this tier of needs very well would have a way to first know about the issues. So this relates to kind of alerting, for example, being able to tell when something is wrong when it meets a particular threshold. It might have to do with diagnosing and remediation of the issue. So this could be if you measure things like a very mature system that has a good way of managing data incidents, might have a way to measure time to resolution, for example. It might be things like your service, like your SLAs, whether it's informal or formal. And finally, kind of a bit more forward thinking, you have kind of how you can prevent these issues again in the future. So this might be, if you start noticing that there's a certain pattern among your data quality incidents, and you kind of try to find commonly called as like root cause identification or root cause analysis, you might come up with kind of solutions or patterns which relate to preventative parts, at the very top of that hierarchy. And the thing here to say, I think, is it really varies depending on kind of your company or your domain. It really depends on kind of what it means to have a good data stack, because keeping in mind you'll always have data quality issues. So as an example, I kind of put down, it's maybe something that's where insights are really easy to generate for analysts, or perhaps it's really easy to kind of evolve. As the business needs evolve and you can adapt to it quite easily without breaking various components, that would be a measure of something that's, that you've reached the top tier, so to speak. So I put this here also because if I've lost you in the past like 5-10 minutes, data observability as a concept, in my opinion, is also evolving. So kind of, even if you didn't catch much of that, I suppose, just know that at its core, I would say it's about data quality, and it's a bit about how you detect, diagnose, and prevent these issues. So that's at a core, I think, what observability as a concept is. And it's changing too. So you probably have heard a lot, if you've read any data blogs within this year, kind of an explosion of content around generative AI and kind of various potentials and applications. So for example, you can use it for data management. So yeah, so I guess it's to remind you that it's not a static concept. It's constantly evolving. And not just is it constantly evolving, I think it's you have to hit peak expectations. So if you're familiar with this is the Gartner kind of hype cycle curve. This is the one from this year that applies to data management. If you're not familiar, the concept is it kind of goes from a particular technology, goes up from when it's first infancy, and then it kind of really grows in hype, and lots of people cover it, think there are lots of solutions for it. There are various startups, etc., or various open source or commercial solutions for it. It reaches a peak of inflated expectations, and then it comes back down. And people realize, like, here are all the actual nitty-gritty problems, and then it kind of gradually kind of comes off in this, what people call the slope or plateaus into enlightenment. I think this is more of an art than a science. I know this is a data engineering track, so I'll also point out, for example, that data engineering is at the bottom of the trough of disillusionment. So whether you agree or not, I'll leave that up to you. But in this kind of assessment, for example, you see observability as something that's kind of riding up the hype train and perhaps is about to might come down in the future. Next, I'm going to go a bit into the next part of the talk, which kind of gives you a brief overview of the various players, the who's who of data observability. The main thing to keep in mind is that it's not exhaustive, because I didn't want to list off a long list of tools, but I'll try to give you the core concepts. So this here is something from LakeFS. You might have seen it previously. It's a map of the current state of data engineering. And it, for example, splits off various sections, like open data formats. You have things like ingestion, data lakes. And the thing that I want to highlight is that column in the center called data quality or observability. So the other thing I would probably point out, which I'll mention in a bit, is the bit at the very right is also quite relevant and kind of has a lot of, in my opinion, synergies between observability and governance. So governance is things like your data catalogs, making sure that you are compliant and things like that. And if it's not clear to you, it hopefully will be by the time I go through the next slide about why they're kind of a good relationship between the two. So zooming in on this part of the landscape, I'd probably say that a lot of these are mixed source. So mixed source kind of is a more, I suppose, less used term, but it kind of describes a particular tool which could be have open source components, but also potentially offer a commercial product as a accompanying solution. Many of these may originate from or better fit a particular ecosystem. As you can tell, like at the bottom, maybe like things like DQ from AWS Labs. I don't use laser there. Great Expectations, for example, is kind of famously integrated with lots of different ecosystems. If you use DBT, I don't know if any folks here do. Elementary, for example, fits really well with that. So there are some that fit better with others, and there are some that offer a kind of a Blade Cloud product. So usually this is instead of a self-hosted solution, they will offer something that's paid, and that applies to quite a few of these tools here. The other thing to say is that many of these are currently choosing to build integrations, especially with enterprise solutions. So one example could be Monte Carlo, which I'll go into in a bit later, which is right here. And increasingly, a lot of the giant end-to-end lakehouse solutions or PaaS offerings, I don't know how many of you here, I don't want to turn this into a kind of name-dropping exercise of particular commercial solutions, but the two kind of giant PaaS offerings of Databricks and Snowflake are both increasingly kind of expected to have some element of observability coming out of the box. The main one from Databricks is called Unity Catalog, and for Snowflake, they've taken the approach of using marketplace apps. So a third party would integrate, for example, Monte Carlo. If they want to have a particular integration, they might build a third-party app that you can then download from the third-party marketplace. That aside, what actually are the pillars, kind of what are the foundations of data observability? Well, it depends on who you ask. So there are 3 to 5 is the common answer that I found online. And I'm going to briefly walk you through what some of these mean. We'll start off at the very left. So here I have something from the book Distributed Systems Observability. So kind of this is what I meant earlier when I said observability is something that was borrowed or adapted from software infrastructure management. And the 3 pillars of observability, as you might have heard, is logs, metrics, and traces. So I suppose, just as a quick recap, for anyone who is not familiar, for example, logs would be something that is a immutable timestamp record of your events. So it probably has existed since the beginning of computer systems, and it's things like log a particular event if your computer turns on, if a particular thing goes down, etc. Traces is to do with kind of the end-to-end complete journey of your request. So I frequently think of it as if you go onto a browser and you look at the inspect window in Chrome or your browser of choice, then you can kind of refresh and see the network log, and then it kind of shows up in a waterfall diagram. So that is a good example of a trace, basically, when one request unified by a trace identifier, in this case your kind of GET request, gets unified. So the whole journey gets mapped out as a trace. So it has to do with when events have relationships to each other. And finally, metrics is just a numeric representation of, in this case, reliability, though it really could be lots of different things as well. So that aside, that was where it started, and it's kind of grown more to various other pillars. So next we'll talk about the one at the bottom. So this comes from I got the name wrong, Bar Moses. She's one of the co-founders of Monte Carlo, which is I think currently, apologies if I get it wrong, I think Series D kind of data quality solution. And this blog is from some time ago, but it kind of tries to adapt these three pillars into what she thinks, kind of what the Monte Carlo product, for example, thinks is the most important parts of observability. So for example, you might get things that are very intuitive, like volumes, or how much you're expecting the data to come through. Freshness, has it been updated today or hourly or whatever your expectation is. You might get things that we already covered earlier, like distribution, so kind of other outliers. And also like a bit more specific to perhaps downstream changes. This is your ETL and transformations around schema and lineage expectations. So this could be things, especially when you try to evolve your schema, problems that occur relating to mismatches of what your expectations are and what ended up happening when you kind of submit the code for schema changes. And on the right here, I'll also mention something from Metaplane. So this is another solution in seed round that is a bit newer and also getting quite a bit of traction, a commercial solution. And this I pulled this from the blog. And it outlines 4 pillars of data observability. I won't go through the main bits of it on the left, but the interesting distinction here is they make a kind of differentiation of characteristics and relationships. So on the left, you had things like metrics and metadata, which is very similar to what we covered. And on the right, you have kind of how these objects relate to other entities within your data ecosystem. For example, kind of table, column, and file level lineage, and also things like logs. So kind of things like how many people query your tables, how they're used in the BI layer, and source your target replication, which is kind of an example is if you, in some cases, duplicate a whole table into your warehouse, you might expect it to, for example, have certain values, like to only happen once a day, or there are real-world constraints that mean that a certain value cannot exceed or kind of be lower than a particular value. So that's kind of what this relates to, and it's to do with, I suppose, anything beyond data engineering, I suppose. So kind of it's to do with your colleagues, kind of who's analyzing the data and trying to derive value out of it. So that aside, I guess the point I'm trying to make is that there is no one answer as to what is kind of the most important parts, or what are the main pillars of observability. What I just went through earlier covers, I think, a lot of it, or the current state of it, at least. But the point I want to stress, and has been my experience as well, is that fundamentally, you're generating data about data. So in many instances, if you know XKCD, they have this one here where the guy says, look, we have a bunch of data, I'm going to analyze it. And then someone says, no, you fool, that will only create more data. So you end up in this kind of situation of a data trap where obviously, if you have any experience with integrating observability solutions, you might have something out of the box called coverage. So you might say, your pipeline only has 85% of models with kind of tests added. And you might have this kind of intuitive urge to try to chase 100%. And I guess this is a reminder that a lot of things, while things that can be measured, they're not always worth measuring. And things that are worth measuring cannot always be captured. So this is a kind of reminder to think about, so then what should you be capturing when you have an observability solution? My answer is as follows. So I think the first thing you want to consider is what layer that your metric is trying to target. So we went through a few examples earlier of ingestion stage. So this is something that you might already have or be taken care of relating to how quickly, how reliably your data comes in through the system. I think the later stages is something that's quite interesting, the source stage and MART layers. These go by many different names. I don't know, you might know them as bronze, silver, gold, etc. But essentially, think of source as like really messy, and think of MART as like really usable, things that you connect your dashboards to. So depending on each stage, you might, for example, for source and stage, you might find a lot of value out of the things that we talked about on percentage of nulls, things like distribution and freshness. And for things like MARTs, you might have kind of particular data tests that says this KPI cannot exceed a certain threshold. The second thing I want to stress is that it really depends the type of data that's being processed. The first thing I'd raise, which you might relate to, I'm not sure if you do, is the level of cleanliness that you can reasonably expect of your data. So whether you're capturing things that are server-sent versus client-sent telemetry, you will have different expectations. For example, client events can be spoofed, for example. You might notice lots of things like localization issues. So I guess the thing to say here is there will always be a level of quote-unquote dirtiness to your data, and it's okay to have a range of acceptability when you write these tests. And the other thing to say is, for example, if it comes from the web, if it's unstructured data versus like telemetry, or something that's a lot more structured like databases. The other thing I want to say is it really depends on your domain. So this probably it's bear repeating, even though it's very simple, but your past is an indication of what your past problems are, an indication of what you might see again in your data stack. So for example, if someone within kind of your circle of work kind of comes to you and says, why is this data looking like this? Or why does it exceed my expectations? Or can you look into whether there's something fishy with the data? It can feel a bit frustrating, but it's also a really good sign that that data is being looked at and has essentially a dependency. And in that case, I think it's a really useful place to start, depending on where you are on the journey, to see what the previous thorny or recurring issues are. And obviously, if you have the time and capacity to do so, you can also start measuring yourself without hopefully it being overwhelming. So most commonly, this is metrics like time to resolution. And also things like time from discovery to resolution, any business impact if you have on measuring things like that. And finally, also just to mention any schema enforcement or other enforced constraints. So this is things like data quarantine, if you've heard of that. So increasingly, a lot of solutions like Unity Catalog that I mentioned have particular features where you say, it's not really as much about being able to tell how good my data is. It's kind of being able to exclude it or do something with it automatically so that I don't get pinged when I don't want to get a ping outside of hours. So this is things like, if you meet certain conditions, then the data might go into data quarantine, or you might still ingest it and then apply certain conditions for it so you can check for it later. That's it. I guess my parting thoughts are you'll probably hear more about observability, hopefully, regardless of your level of understanding of the topic that you found this useful. The best tool is the one that fits your current stack and what your needs are. And finally, that the best data quality metrics are the ones that get actually actioned on. So you don't want your team to get desensitized to particular alerts. And I think this is one of the good things that kind of, as a reminder, it's really easy to kind of write lots of, or especially when you adopt these tools, to think it's all about breadth, but equally as important is about the things that you do action on. So that is the last thought I will end on. Thank you.
Because there are some questions. And yeah, thanks a lot for a good overview of data observability. And we have quite a few questions. Unfortunately, we do not have time for all of them. So I will take the most upvoted question, which is measuring quantitative qualities of data is now easy, air quotes, with all the tools that you presented. But now the great pain for data professionals is knowing what is in a certain table, right? So we can observe what is there, but knowing what kind of data is in each table is problematic. And the question is, do you know if all these generative models, LLMs, can help with that?
That's a really good question. And it kind of reminds me a bit of the meme that I put up of what generative AI can do. And I'm guessing I won't be the only speaker that gets that question today. I guess the thing I would like to say is maybe something I didn't elaborate on as clearly earlier when I said there's a link between observability and governance and cataloging, is because I think frequently, kind of to your point of whoever asked that question on like what is in your tables, that is more of a cataloging question, right? So that's kind of to do with what are your data assets. It's on the right-hand side of that landscape map I showed you. I think it's less about, in my view, kind of what LLMs can do, but also, because it can do a wide range of things, in my opinion. But what it can do for you, that's the more important part. So I think that's why I ended on those thoughts on, adapting it to your system, starting small and making sure you are actioning on your alerts that you're getting. Mm-hmm. I think that's probably more important than...
Have you come across any product that already tries to utilize LLMs for data cataloging?
So a lot of those tools earlier, for example, Monte Carlo, et cetera, we don't want to turn this into a sales pitch, but a lot of them would say they are AI powered. So a lot of that essentially would involve either something that's very simple rules based or something that's trained on a model on particular previous incidents. I would say I would put that in the category of AI powered.